So in today's lecture we are going to talk about how to use CircuitMaker. In fact, it is one of the very easy to use software. Through this we can simulate various electronic circuits. So in this video we'll use different general circuits, for example resistors in series and parallel, use of Kirchhoff's voltage law, rectifier circuits, etc. by the help of CircuitMaker. So the document I'm having, I'm using it for the questions, and I will simulate circuits for the same. Hope you have the document. If you don't have, write your email in the comment section. I will mail you the document for your reference. For example, directly let us go for the question. The first question is design a circuit which is given below and observe the current I. We've got a battery and a resistor. Value of battery is 12 volt and resistor is 600 ohm, and we have to calculate the current. As first I have solved it theoretically. We know as per Ohm's law I equals to V by R, that is 12 divided by 600, which is 0.02 ampere or 20 milliampere. Now this is the screenshot of the circuit, but we'll start from fresh, and here we are. Now your CircuitMaker, once you will install, it looks like this. If you don't know how to install, you will find it in the document in the first page. So as clear from the circuit that what we need is a battery, a resistor, and a meter to know the current. Fine. So here we are. First of all, see this, whatever you need, just for example general, a resistor, and we'll click the first one, the basic one. If you double click, you will get like this. Now what else we need? We need battery, right? So you can see battery. Double click on this and move your cursor. Wherever you will move, you will find your battery. Okay, now we need a meter. For meter, it is not there in the general section. You have to go to the instruments. I is here. In this, go to multimeter, and again double click, and you will get. You see, this is the important thing. You have to make sure what you are looking for. If you want resistance, the radio button for ohm should be selected, but you want current, so this will be the case. And we to DC current, because we have got a battery, so click OK. Now we need grounds, because in every circuit ground is important. For that, again go back to general, then sources, then double click on the ground, you will get it. So here we are. Now we have got all the required things on this page. Now to connect, you have to click on the plus sign. It is called wire tool, that is displayed right now on the screen. So click on this. Now we have to connect this battery to the meter. Another terminal of the battery will of course go to the ground. This resistor will go to the another terminal of your meter, and another terminal of the battery will go to this ground. So we are done. But if you go back to the question, value of battery is 12 volt and resistance is 600 ohm. For that, to change this, again go to the arrow, so that arrow tool, it will be normal. If you want to change the value of this battery, double click, and it's 10, just change 0 to 2 and click OK or enter. You see this value will be changed. This 1 kilo ohm, you want 600, so there are two things you can write. You can remove kilo and write 600 only, or 0.6k will give you the same thing, 600 ohm. Now we are done. Once circuit is prepared, circuit is made, this is the place to run and get your output. So just click, left click on this. Now you can see 20 milliampere is coming. So we will go back to the section, and you see your theoretical answer. It is 20 milliampere, and our circuit and like this, and our meter is giving this. So we are done with the first experiment for today. So well done. Now go to the next question. read it carefully. The question is, design a series combination of two resistors for resistors of 1 kilo ohm each, an input voltage of 10 volt DC. Fine, two resistors of 10 kilo ohm and 10 volt DC. Calculate the value of current. Now, at first, again, the practice is I always solve the theoretical value, then I compare practical. Since the resistors are in series, the total value will be R1 plus R2. 1 plus 1 will be 2 kilo ohm. Current will be voltage divided by total resistance. Voltage was there in the question, 10 volt, and total resistance we have just solved, 2 kilo ohm. So 10 divided by 2000 is 5 milliampere. So your circuit will look something like this, and most important thing is we will run and see if our meter must give the same thing. Now go back to your CircuitMaker. So we have got two resistors here. Now I will to make it presentable, I will keep both of the resistors at the same place. Now what I will do, I will connect this by clicking on the plus sign. I will connect this meter to one terminal of the battery. Under will go to ground. This resistor will go to the another terminal of battery. Since they are in series, they must have a common point. Another terminal of your resistor should go to the ground. Now again go back to the question. Value of battery is 10 and two resistors are 1 kilo ohm each. So how we can change the value? By double clicking on the element, by changing this is 10 volt, 600 you can write 1000 or 1 kilo, the same thing. Last is again 1000 is 1 kilo. We are done. We need to run. We will click on this button, just click this. So this is our reading and we are getting 5 milliampere. Now if you go back and see your value, the theoretical value is 5 milliampere and we have got the same. So it was again very simple. Now the next question is a bit change. Design a parallel combination of two resistors, same value is 1 kilo ohm each, and value of battery is again same 10 volt. So there is small difference in the calculations. Since two resistors are 1 kilo ohm each, the formula for total resistance is multiplication on the numerator and addition on the denominator. If you solve, you will get half kilo ohm is the total resistance. So the total value of current will be voltage divided by total resistance, that will be 20 milliampere. Now we will go back and we will stop. It is still running, so to stop you have to click here and we will rearrange to get the circuit we are looking for. I will rotate these two resistors, rotate 90 degree, the just so it will look a bit more presentable. And now I will rearrange them again. For wiring I will connect them. You see we are getting this 5 milliampere in the meter, that is the previous result. We are not worried about that. At first we will make our circuit complete, then we will run. I think we are done. You see its value is 5 milliampere and it must change. Let us see, I am running and see the value, it is 20 milliampere. So again go back and see your values. It was 20 milliamperes. It means we have got the answer we are looking for. So this is question number 3. Now go back to the next question. For the given circuit, calculate the voltage in resistor 1 kilo ohm. We have got 3 batteries and 1 resistor, and we have to know the value in this resistor. It is in fact a solution for Kirchhoff's voltage law. So in this case again, at first I have simplified it theoretically. I started from this point. I have again made this picture, and this is like a closed loop, and I am starting from this point, and if you will go solve KVL, it will -5 because you are getting minus terminal, then +6 plus I have assumed voltage here is VR that we need to find out, and finally -8. The addition of all the voltage is 0, and if you simplify you will get 7 volt. In practical circuit, in CircuitMaker, just connect 3 batteries, 1 resistor and a meter in parallel to the resistor. The only difference is in earlier meters you are looking for current, but here you need to know the voltage, so you have to change the requirement in the circuit. Let's go back to the CircuitMaker. Now I've got the 3 batteries, 1 resistor and 1 meter. You know how to connect. Just click on this. This battery is connected to the another battery. This battery is connected to another battery. This resistor is connected to a battery on top, another terminal to battery on bottom. This meter somewhere near here and here. I think we are done with the circuit. One important thing still left is this meter is now giving current and we need voltage, so we just go right now. You see the radio button for voltage will be selected, and that's all. And let's run this. You see this is 7 volt as per the CircuitMaker simulation. Now as per our analysis, theoretically the value was same, 7 volts, so we are done. Now let's go to the next question. This is a very interesting question. Design half-wave rectifier and observe the output waveform for an AC signal of 5 volt. So you know what a rectifier does. A very simple AC signal. Earlier example we were using DC, but we will use AC signal here. 1 diode and 1 resistor, and we will see. And you have to be a bit careful because it is different from others. So if you want to clean the screen, just go to new schematic. If you don't have to save, just click no. And as earlier I was telling that what we are looking for is ground. Always we need. Double click, you've got ground. Now if you need an AC signal, go to instruments, signal generator. You see here you see the cursor. Double click, you will get signal generator. We have got the AC signal. Now diode, where will get diode? So here it is. Go to diode. The first simple diode we have got, and always we need a resistor to collect or to see your output. So double click on this resistor. So our resistor is with horizontal. We'll keep our mouse here and right click. I want to rotate this, rotate 90 degree, so it will be a bit more presentable. I will keep it bit up. Now wiring is needed, so you know the way it will be connected in the input. Another terminal will be of course grounded. Your resistor will be connected here. Another terminal will be of course grounded. And the next point was, in your question your signal was 5 volt AC, so we have to make it. Just double click. It is peak value is 1, so just make it 5. Enter. Our circuit is done. Now see it carefully. To run, just we have to click this. This is our output screen. If you want to see the input signal, which is 5 volt, you see the signal. We have got complete signal in the input, but you see we are near our input signal. This is our input. Where is the output? Near this resistor. Just keep your mouse here and click, and you see half wave. You know very well that only half of the input wave will come, and this is what we have got in the output. This is the way we can design this circuit. Now the last question is, we have got a circuit in which we have got a 24 volt battery, 3 resistors arranged in the way shown in the figure. So in this case we have to calculate how much is the current here. Hope you are now very much familiar. Battery, 2 resistors, another resistor and a meter. So this is an assignment for you. I want you all to see this circuit carefully and draw and make sure that you are getting output, and they are both same, theoretical and practical. That is all for this class. Hopefully we will discuss something else. If you have got some other questions or you need any clarifications or any feedback, you can always add your comments below. Thanks. Bye.